Hey to everybody. Now, this is a series in which we will be covering examples in univariate analysis. Each video will show a particular example or a caselet. Now, test for equality of means large sample is the example that we will be discussing today. Before we go ahead, you that here we will be considering the sampling distribution of the difference of means. In the sense, there are two populations. As you can see in the video, there's a pink population and a blue population, and each population has its own mean and standard deviation: mu1 sigma 1, mu2 sigma 2. From each population, we pick up a sample from the pink population and a sample from the blue population, and each sample provides us with a mean and with the difference of the two means. So every time we do the sampling, we land up with the difference of two means and a set of numbers, which is the sampling distribution of the difference of means. So now we have a different kind of a standard error computation, which is based on you can say the computation of variance of a combination of two samples. So this standard error computation is that it is root of sigma 1 square by n1 plus sigma 2 square by n2. Now this is a small caselet. We have to test whether two similar machines are producing articles of equal average weights. A1 and A2 are two machines, and they are found the standard deviation of weights produced by these machines is 0.13 kg and 0.15 kg. And two samples of size 40 and 50 were taken from the products of the two machines. The sample mean weights are 1.05 and 1.10. Hypothesis is the two means are equal. That is, the mean weight from the first machine and the mean weight from the second machine would be the same. And the alternative hypothesis is that the two means are unequal. The first step is we compute the standard error. Sigma x1 bar minus x2 bar will be root of sigma 1 square by n1 plus sigma 2 square by n2, and in case the population standard deviation is unknown, we take the sample standard deviation as an estimate of the population standard deviation. In this case, standard error is computed as 0.0295. You notice the Z is difference between the actual sample means minus difference between the hypothesized sample means. So in this particular case, the null hypothesis states that the two means are equal. So difference between the hypothesized sample means is 0, and that is divided by the standard error. So that would be 1.05 minus 1.10 divided by 0.0295. So in this particular case, we are getting a value minus 1.695. For being 0.05, it is assumed, not mentioned earlier. So our critical Z is plus or minus 1.96. If you can see from the graph, minus 1.695 lies within the acceptance region, and thus we would accept H0.